Hello there and welcome to this no-nonsense practical series on circuit simulations using LTSpice. SPICE here stands for Simulation Program with Integrated Circuit Emphasis, and it's a very old software package that basically numerically solves the differential equations that defines the circuit that you design and allows you to perform different kinds of analysis. In this series, we're going to start with transient analysis, but we will get into other forms of analysis. To get started, you have to head to analog.com, or you can basically just Google LTSpice and then just add analog to it, and then just come to analog.com, look for the one that says download LTSpice, and just click on that and download the version that is right for your operating system. I already have this installed, and so I'm not going to download it anymore. What I'm going to do here is to just start it, so LTSpice, and I'm just gonna open LTSpice here. Alright, so this is how the user interface might look when you open it, and the reason I'm saying that is what you see also depends on the version that you have, but in my version this is how it looks like. And regardless of the version, you're going to have everything that I am going to show you. So once you have the application opened, the first thing you want to do is to create a new file. So when you click on this button here, you can see there's a tooltip that says new schematic, right? All right, so once you've clicked on that and a new schematic sheet has been created for you, let me brighten the screen a bit. A new schematic sheet has been created for you. The first thing that you want to do is to place component that defines the circuit that you want to build. Up here you can see some commonly used components. So this is for ground, this is for drawing wires or connectors between your circuit component, this is for a voltage source, obviously this is a resistor, this is for a capacitor, this is an inductor, a diode, and then if you don't find the component you want to use up here, you can click here to actually go in here and be able to search for the many components that are available in the software package. Because this is our first video, I'm just going to show you how to do some schematic capture. And what I mean by schematic capture is basically just drawing up your circuit. Okay, so we are not going to do anything complicated. We're going to start by left clicking on the voltage source, and then you come to the space here, you drop it there. If you have a mouse that has a third button, which is a mouse wheel, then you can use it to zoom out or zoom in. So you also want to have in mind the final size of the circuit you're about to build, so that you will determine what sizes are appropriate for the components that you place. So it might look very big like this, but you can always scroll down or zoom out and zoom in to get it at the requisite size that fits your need. So I think this is okay for now. I'm zooming out a bit, then I will place it here. Now once you place the component, you can still place it multiple times. So you can see that whatever component I selected is what is still showing where my mouse pointer is supposed to be. If I'm done placing that particular component, what you have to do is to press the escape button, and that is going to let it go. Now once you have placed, if you click and drag around, you'll be dragging around your entire circuit. So over here I just have one component, which is the voltage source, but if I had multiple items there and I clicked and dragged around, I was going to drag all of them together. If I want to move a particular component, you can press the M key and then it turns it into this icon, and you can click on what you want to move and then you move it alone. Okay, so always remember that. Once you're done, you can press escape to exit the most recent tool that you used. For this video, because it's the first one, I just want us to do a very simple circuit simulation. So I'm going to pick a resistor here, and you can see that the resistor I picked is in the up down position, right? If you don't want it that way, you just press Ctrl R, and that's what's gonna rotate your component for you. I want it to be horizontal, so I'm just gonna place it here like that. And because I don't want to place any more resistors, I'm going to press escape on my keyboard. All right, now the next thing we have to do is to draw wires to connect the circuit, right? To connect the component in the circuit. You can either click on this button here, this icon up here. Let me drag back. You can also press W. I like to use the shortcut keys, okay? So I'll always tell you which shortcut key I'm using. So I press W on my keyboard, and then now I click, and then once you drag, you don't necessarily have to hold, okay? I click and drag. When it gets to the point where I feel I can bend to the other side so it goes through the component, I just click once more, and then I drag it in the direction. The good thing about LTSpice wires is that you can actually route it through the component, and the program is smart enough to recognize that it doesn't have to go through the component. So if I click here, I come down, you can see that initially I dragged it through the resistor, but in the final drawing it is not so. So I come here and I connect it to the end. Now you can see that the mouse is still showing the wire tool, so you always have to remember to press the escape key to leave the most recent tool that you selected. Now we have a basic circuit here. One thing that you shouldn't forget is to always add a ground to your circuit. So I'm going to pick the ground symbol, and then I'm just going to put it here so that it always knows what is the reference point within your circuit. Having drawn the circuit like this, there are things that we need to do before we can actually start the simulation. And the first one you want to do is to specify the values of the components and the voltage sources that you have in your circuit. To do that, to edit any property of a component, you have to place your mouse pointer on that particular thing you want to change, and then you right click. Pay attention and recognize that you can see R1 here and V1 here before you see V, and then you see R. The R1, V1, they are the component designators. So if I added more resistors, I was going to see R2, R3, blah, blah, blah. If I added more voltage sources, they are going to increase by 1. What you actually want to edit is not the component designators, not because it is wrong to do so, but you actually want to focus on setting the values to match whatever simulation you want to do. So you put your mouse pointer here on the value and you right click. Now when you right click, you can enter the value. So because this is a resistor, I'm going to enter 10K. The beautiful thing also is that LTSpice understands these 10K, 10M, you know, all these units that signifies multiple zeros, or after 10 or multiple zeros before, right? So you click here and you can see that now this is a 10K. You also have to set your voltage properties, right? Now if I right click just here, I can enter the voltage, okay? But this component is more complicated than the resistor you see here. With this same voltage source, I can generate AC signals, I can generate square waves, I can generate ramps, pulses, and also DC. So the best way I do is to right click in the component itself. So you see, if I right click on just the value, what you see is different from when you right click in the component itself. Now over here, you can set the DC value of the voltage if you just want a straight DC source, and if you also care about the series resistance of the voltage source, then you can specify that. However, if you also want something more than just a DC voltage, maybe you want a pulse, you want sine, exponential, these are all stuff we'll have dedicated videos for them. So for now, you can just enter let's say 5 volt here, and once you enter it in the DC section, all of these do not apply, okay? So if I click this, you can see that now it's a 5 volt. So what I want us to learn from this simulation is, if you connect a 10K resistor to a 5-volt voltage source, what current is going to flow and what's also going to be the voltage across the resistor. Obviously, you don't need a simulation to know what's going to happen here because of Ohm's law, but we need to start simple before we start doing complicated stuff. Now that you have set the values for your components in the circuit, the next thing you have to do is to tell LTSpice about the kind of simulation that you want to do. And to do that, you have to click on this button here. It says configure analysis. Okay, there are actually multiple ways you can do that, but just click on this configure analysis. This is the point where you are able to choose the kind of analysis you want to do. We can do transient, we can do AC analysis, DC sweep, noise, DC transfer, blah blah blah. These are all stuff we're going to get into. Again, let's start simple by doing just a transient analysis. What transient analysis basically means is that LTSpice is going to numerically solve the differential equations that defines this circuit for the time frame that you specify, and then is going to keep values of the voltages and the current within the circuit. So basically, transient analysis looks at how voltages and current change in the circuit with respect to time. And for this very simple circuit, it doesn't matter how long we set it because we don't have any component in here that is going to react based on time. For example, if we had a capacitor or an inductor, it doesn't really matter in this case. So I'm just gonna simulate this for just 1 second, and you can just type 1, and if you don't add any unit to it, it's understood to be second. But if you want to be pedantic, you can also add s to it, and then now you can click this. Now it's going to give you this directive, and then you just have to put it anywhere on your circuit, just so people looking at this also have information about how long the simulation is going to run and all that. So now that we have set this, the next thing we do is to just click on simulate. All right, so now it looks boring, right? So you click simulate and you are seeing this plot up here which doesn't really show anything, and then you have your circuit down here. But this is where things begin to get interesting, right? So if I hover my mouse pointer, across any component, it is going to help you. So this red probe thing is going to help you to probe the voltage at this particular point in the circuit. All right, and then if you pass it on the component itself, you see that it changes. It looks like a current sensor that is clamping around the cable. So this is where you click if you want to know the current that is flowing through the particular component. I mean, this is a no-brainer. It's a 5-volt DC supply. So if I click here, I expect that I'm gonna get 5 volts. So this is giving you sort of a software oscilloscope for you to be able to probe around to see what is happening in your circuit. So you can see that, of course, it's a DC 5 volts, and so I only have one resistor, so the entire 5 volt is going to be dropped across the resistor. So it's not going to matter where you click here, it's still going to be 5 volt, right? Now if I want to know the current that is running through the circuit, I can go to the resistor, click here, and you can see that my current is here. Now it might look a bit confusing, like, you know, when it was just here, when I clicked voltage, it plotted it in yellow and it was just one thing showing. Now when I click another to measure the current, the voltage is still around here, but the current is here. So you have to read the current from here. So it's telling you that 500 microamps is what is running through this circuit at the moment. One thing I want to show you before we close is, if you want to see just one value on the graph, then you have to double click. So if I double click on this, you see that the voltage is gone and the scale has also adjusted to accommodate the fact that I'm just looking at the current. So I still see my 500 microamps running through the circuit, and if I come here and I double click, you can see that it's only 5 volt, of course, which is coming from the DC source. So this is simply how you get started with LTSpice. When you are done and you want to save your circuit, you can just click the save button and then save it, so that you can later resimulate it with changes that you want to make. But it's as simple as I've shown you here. Don't be fooled by the simplicity of what you've seen, because things would get very complicated and you will see the power of this tool. Thank you very much for watching, and I will see you in the next.